Hi, welcome to our maths and statistics class. This is session number 3, looking at statistics. In our first session, we looked at general concepts of statistics and the measures of centrality, the calculation of the mean, median, and mode. In our session number 2, we looked at the measures of dispersion, standard deviation, the range, the variances, and the coefficient of variations. That's what we considered in our session number 2. This session number 3, I'm going to look at measures of dispersion still, looking at the calculation of standard deviation for a simple set of values. In our session 2, we looked at the calculation of standard deviation for a grouped frequency distribution. Now we are going to consider the calculation of standard deviation for a simple set of values. And the other thing I'm going to do in this particular video is to look at how to calculate standard deviation when you are given a probability distribution instead of a frequency distribution. So let's understand what a probability distribution from the onset. A probability distribution is a statistical function that describes all possible values and likelihoods that a random variable can take within a given range. That's what a probability distribution is. So in simple terms, instead of giving you the frequencies for the data, they give you the probabilities for that data. That's what we call a frequency, a probability distribution. So we are going to go to our question paper that we've been looking at. We've been looking at 2018 June CA 1.2 final exams, and that's the question paper where currently I'm picking some questions to be used as examples there. So straight away we go to that particular question paper. Okay, so there we are. This is CA 1.2. This is June exam, June 2018 exams for CA. So let me go straight to section A of this paper. We are looking at question 1.6. That's the first question we are going to consider. Question 1.6. Okay, so there we are. Question 1.6 is a question on standard deviation. Now here they are asking us to calculate the standard deviation for a simple set of values. The question reads, a financial institution records the following number of clients getting loans on a particular day from 4 different branches. So we have 3, 5, 12, and 2. Calculate the standard deviation for this data. So this type of question is different from the one we considered in our session 2, where we were given grouped frequency distribution or group data. So let's see how we can calculate the standard deviation when given a simple set of values. Let me open our answer page. Okay, so there we are, answer page 1.6. Now, I've highlighted the 2 formulas there for calculation of standard deviation. So one of these formulas, the first one here, is the formula you use when you're given a frequency distribution. And the formula has got frequency in it. So you can tell that the reason why we have frequency in the formula is because it's supposed to be used for frequency distribution. If you look at the other formula there, this one has got no frequency in it. So that's the formula you're going to use for a simple set of values. Now, I want to remind you also about what we said in our session number 2, that the reason why we have a -1 at the bottom there, why the denominator carries a -1, is because you are dealing with the sample. If you are dealing with the population data, you don't have to subtract 1. So the first question we dealt with, the data was about the sample. This question also, the data is about the sample. We are just sampling from the whole lot of information that is given about that data. So because we are dealing with the sample, we always have to subtract 1 from the denominator. If you are dealing with the population data, you don't have to subtract 1. Now, a question will always highlight whether you're dealing with a sample. They may say straightforward, this data is about the sample, or they may indicate this data is about the population. But even if it's not indicated straight away like that, we know what a sample is. A sample is just few elements selected from the entire population. So if you are talking about data where you just select few things from the entire population, you can still tell that this is about the sample. So let's go back to the question and just pick the information that we need. Now, back to the question. The question is saying the data given here is coming from a number of clients getting loans on a particular day from 4 different branches on the particular day. So we're sampling that data. So we have 3, 5, 12, and 2 as the data. So back to our answer page. So what you need to do here is in statistics, we like using tables, so you can insert a simple table that can help you to get the information that you need. This table is going to be based on what you need from the formula. So from the formula here, we need the summation of x squared, and we also need the summation of x. So two columns will do, one column dealing with x, the other column dealing with the x squared. So let me just have two columns for this type of data. Number of rows depends on the values that we have. Okay, so that's the table that will help us get those values. So let's say here we have our x values, and here we have our x squared values. X squared values. Alright. So we have our x squared values. So x squared values. So let me pick the x values that we have from the question. This is 3, 5, 12, and 2. So 3, 5, 12, and 2. So we have 3, 5, 12, and 2. All right. We need another column for the summations, all the totals. So let me just add more one. We need another row, another row for the summations. So let's insert the row below. There we are. That is going to help us with the summations of x and the summations of y. So I can even put that in bold. All right, so let's get our x squared. 3 squared, that would be 9. 5 squared, that is going to give us 25. 12 squared, that's going to be 144. Okay, so 12 squared, 144, and 2 squared, that's going to be 4. Summation of x, we are adding 3 plus 5 plus 12 plus 2. When you add those things, you must get 22. All right, 3 plus 5 plus 12 plus 2, that should give us 22. The summation of x squared, 9 plus 25 plus 144 plus 4, that should give us 182. So you have those figures, you should get 182. Well, now we have what we need. So we can bring down the formula here and insert those values in the formula to get our SD for this data that is given. So let me just copy that one. Let me cut it, bring it down here. Alright, now let's substitute the values. We have our summations here. Summation of x is 22. Summation of x squared is 182. So where we have summation x squared, there we have 182, and summation of x here, we have summation of x there. We should have 22. Okay, so 12 plus 2, that's 14, plus 5, 19, plus 3, 22. So we have 22 there. N is 4. So n is the number of values. We have 3, 5, 12, and 2. Those are 4 values that we are adding. So n is 4 as well there, so 4 minus 1. So punch that into your calculator. You should have x squared, you should have SD equals to the number on top there. After working out everything, your numerator should be 61. So after working everything, you have 61. Then the denominator 4 minus 1. 4 minus 1, 4 minus 1, you should have 3. So 61 divided by 3, and you find the square root of that. That should give you 4.5. So 4.5 is the standard deviation for this particular data that we had. Wow, that's how you deal with standard deviation when you're given a simple set of values. Now let's look at standard deviation for a for a probability distribution. Let me just push this data down. Standard deviation for a probability distribution. So back to the question. The question should be question number 2B of section B. Question number 2B of section B. So let's just scroll down to section B and look at that particular question. All right, so there we are, section B, question 2. Of course, question 2 was compulsory. We're dealing with question 2, part B. Question 2, part B. Question 2, part B. So the question says a factory manager is considering whether to replace an old machine with a new one. A review of past records indicates the following probability distribution for the number of breakdowns of this machine in a week. So number of breakdowns is given and the probabilities are also given. So required, number 1, find the mean number of weekly breakdowns. Now the mean is the same as the expected value. Expected value for probability distribution, expected value for probability distribution is simply calculated as a summation of x multiplied by probability. So when you get the data in the question, just take the x value, which is the number of breakdowns, and that multiplied by the probability, the appropriate probabilities. So expected value of the mean is going to be 0 multiplied by 0.1, 1 multiplied by 0.26, 2 multiplied by 0.42, 3 multiplied by 0.16, and 4 multiplied by 0.03, and then you get the summation of that. That is going to be the mean. Find the standard deviation. The standard deviation has got its own formula, so let's check our answer sheet there. The formula is the square root of x squared multiplied by p, summation of x squared multiplied by p, minus summation of x multiplied by p squared. So this part in the formula is the same as mean. So once you get the mean or expected value, you can just insert it on that part of the question. So let's see how we can answer this one. Again, coming up with a simple table that will help you do the calculations will be very, very necessary here. So let's look at data. We have the x values, which is the number of breakdowns. We have the probabilities. And according to the two formulas we've looked at, for us to get the mean, we need xp column for us to get the summation of xp. For us to get the standard deviation, we'll need the x squared multiplied by p. So we need about 4 columns for us to be able to calculate those summations. So I'll insert a table that has got 4 columns in it. So we say 4 columns. Okay, so The number of rows depends on the number of values you're given, of course. So we have the x values, the column for probability. We'll need the column for x multiplied by p. We'll need another column for x squared multiplied by p, x squared. So the x squared multiplied by p. Alright, so let's try to get our x values from the question. So we have 0 up to 4 over x values, number of breakdowns. So 0, 0, 1, 2, 3, and 4. Okay, so we'll keep that last row for our summations. Probabilities, we get the probabilities also from the question. 0.10, 0.26, 0.42, so we list them there. So we have 0.10. The next one is 0.26. The third one is 0.42, and the next 16. So 0.42 followed by 0.16. And the last one there is 0.06. So we have our 0.06. So xp, we are multiplying those values by p, the x value by p. So 0 multiplied by 0.1, that's going to be 0. 1 multiplied by 0.26, you get 0.26. 2 multiplied by 0.4, you get 0.84. 0.84. 0.16 multiplied by 3, that should give us 0.42. You can check those figures with your calculator. 0.42. And 0.06 multiplied by 4, that will give us 0.24. So 0.24. 0.24. Alright, so we needed another column for x squared. That is going to help us to calculate x squared multiplied by p. So let me just insert another column. So another column there for x squared. So let's square x. 0 squared, that's going to be 0. 1 squared, that's going to be 1. 2 squared, that's going to be 4. 3 squared, that's 9. And 4 squared is going to be 16. Let's multiply those figures by the probabilities. X squared multiplied by the probability. So 0 multiplied by 0.1, that will be 0. And 1 multiplied by 0.26, that will be 0.26. And we have 4 multiplied by 0.42. Okay, so 4 multiplied by 0.42. I needed to use the calculator there. So just 1 minute. Okay, so we're looking at 0.42 multiplied by 4. That will give us 1.68. So that's 1.68 there. Then we have 9 multiplied by 0.16. So 0.16 multiplied by 9. So we have 1.44. So that's going to be 1.44. And finally, we have 16 multiplied by 0.06. So 16, 0.06. That will be 0.96. 0.96. It is important that you're also checking these figures. So be with the calculator where you are and check those figures out. So adding our XP, summation XP, this value should be 1.82. Okay, so adding that column there should give you 1.82. Adding that column, x squared multiplied by p, x squared multiplied by p, that column should give you 4.34. 4.34. That's the summation for that column. So once you do that table, most of the things will be done. You have the work, about 90% of the work done already just by doing that table. So what's the mean for this probability distribution? The mean for this probability distribution is 1.82. That's the mean, because we say the mean is simply the summation of xp. That's the mean. Standard deviation. What is the standard deviation for this distribution? What's the standard deviation? Again, we have the formula for standard deviation there. All we have to do is to fit in the figures. So we know that summation x squared multiplied by p, summation x squared multiplied by p is 4.36. So let me just copy it down there. So summation x squared p. Okay, so that's the complete formula now. Okay, so summation x squared multiplied by p, the value is 4.34. 4.34 minus summation xp squared. Summation xp is summation xp. That value is 1.82. So we have the 1.82 there. So 1.82 squared. Okay, so tap that into your calculator. Your SD solution is going to be the square root of it's going to be the square root of 1.0276. 1.0276. And when you get the square root of that, your SD standard deviation final answer is going to be 1.0137. 1.0137. That's going to be your final answer. Alright, so that's how you calculate the standard deviation when you are given a probability distribution. If you want to calculate the variance, remember what we said about the relationship between there is standard deviation and the variance C. That standard deviation is the square root of the variance C. So the variance in this case would be the square of the standard deviation, and the variance would be 1.0276. That's the variance. So from that understanding, you can calculate the variance of the probability distribution, the standard deviation of the probability distribution, and the mean or expected value of the probability distribution. The question we are looking at here had two questions on the same. So just scrolling down, question 3b was coming from the same thing. So you can attempt question 3b on your own. Let me just read through the question. It says the company mentioned in part A, Amazing Deco delivers fresh flowers in the range of time that may take up 6 weeks from the time the order is placed. The probability of various delivery times as follows. So you're given delivery times, that those are the x values, and you're given the probabilities. Then the question says find the expected value of delivery time. Expected value is simply the mean. So you get the x value multiplied by the probabilities, and then sum up those products. That would be your mean. That would be your expected value. Calculate the standard deviation of this data. Just apply the formula like we did on the first one to calculate the standard deviation. Now, the other one says calculate the probability that the delivery will take less than 4 weeks. Now, these probabilities are very simple. I know we have not yet done probabilities, but these types of probabilities, of course, will be very easy. So, probability of less than 4, you have 3, 2, and 1. So, you take those probabilities for 3, probabilities for 2, and probability for 1. So it will be 0.2 plus 0.25 plus 0.1, and that will give you a total of 0.55. That will be the answer for that particular question. Okay, so we'll look at probabilities later, but for now we're dealing with statistics. So I want you to have a go on this question. Please pick the question, just attempt to calculate this particular question. It's going to help you to just see whether you understand what we have demonstrated in this particular video. Thank you so much for your time. See you again.